So in today's video, we are going to discuss about reversible and irreversible reactions of chemical equilibria. Okay, so make the heading reversible and irreversible reactions. Okay, so as see the term is saying the definition. Reversible, first of all we will discuss the irreversible, because irreversible is concerned with the chemical equilibrium, right? So irreversible reactions are those reactions which cannot proceed further, which cannot proceed further, right? Which cannot proceed further means let's take one example. Means suppose we have A to B, something is forming. From A to B something is forming. So this B to A will not possible, means this step is possible, okay, but B to A is not possible. Got it? Okay, let's take one example. For example, we have a, that is NaOH, which is a strong base, plus HCl, and it's a strong acid. It's a strong base and it's a strong acid. When you will mix this NaOH and HCl, what will form? It will form a salt, that is NaCl plus water, right? So once this salt will form, student, it is not going to form again this NaOH or HCl, right? Mean this mode is possible. Once this NaCl salt has formed, it is not going to change it further into this thing NaOH and HCl. Got it? So this is known as irreversible reaction. This is known as irreversible reaction. Okay, let's take another example. For example, N2O4. Okay, so N2O4, what it will form? It will form 2NO2, right? It will form 2NO2. Okay, but what happened? If you want to reverse this reaction, this is not going to be possible. Okay, so this kind of reaction which cannot proceed further, or once the reaction happened, you are not going to change it back its original reactant molecules. So those kind of reactions are known as irreversible reaction. Okay, whereas the reversible reaction, let's talk about the reversible reaction, student. Reversible reactions are nothing but these reactions proceed further. These reactions proceed further. Okay, let's take an example. So reversible reactions can proceed further. Okay, these reactions can proceed further. Okay, let's take an example. The best example is N2 plus H2 giving ammonia, NH3, right? So N2 plus 3H2 giving 2 ammonia. So this reaction can be possible, and further from NH3 to NH3 you can make N2 plus 3H2, right? So this reaction is possible. So that is why we are saying this reaction is reversible. Okay, means from A to B, this forward reaction is possible, as well as from B to A, that is backward reaction is also possible. Got it, student? So in reversible reaction, both the mode will operate, like forward as well as backward, whereas in irreversible reactions only once forward reaction will happen. Okay, so this is all about your reversible and irreversible basic change. You can say the basic differences. Okay, so generally reversible reactions, okay, those reactions which are reversible, we will represent it by we will represent it by like this arrow. Okay, so for example, N2 plus 3H2, it will form 2NH3. Sometimes students are very confused. They say, ma'am, this is nothing but it's an equilibrium. No, student, this is not equilibrium. This symbol, this arrow, half arrow, and this half arrow is showing that this reaction is in not equilibrium, you can say, because why this equilibrium comes, because equilibrium, wherever we'll talk about equilibrium, we'll compare the rate of the reaction, means reactant as well as product. Okay, when the rate of reactant and rate of product will equal, we'll say it is in equilibrium. Okay, but those reactions from or you can say those reaction which convert from A to B and B to A, we'll say it is a reversible kind of reaction. So this is a simple representation, you can say. Okay, so I hope it's a very clear from this video that what are the basic difference between reversible and irreversible reaction. And suppose number of reactions are given to you, and like it said that identify which one is reversible, which one is irreversible. So how you are going to identify, right? So by the help of the symbol, you are easily going to identify which one is reversible or irreversible, because in the case of irreversible reaction, student, irreversible reactions, once the reaction has happened from A to B, okay, it will not going to convert back into B to A, right? So only this type of arrow will show. Okay, whereas in the case of reversible reaction, this type of arrow will show. So by seeing these symbols, you are going to identify. Okay, but this is not the basic condition. I'll tell you, this is not the basic condition, because suppose this reaction is in like happen in open container or closed container, then the things will be different, right? Here in the case of irreversible reaction also, if this reaction is happening in open container and closed container, the things will be changed. Okay, so these are the, like you can say, the different parameters which we will not consider here. So I just want to tell you the basic difference between reversible and irreversible reaction through this video.